Today is Wednesday, and you guys are going to be learning my favorite method for solving systems. So yesterday, admittedly, was a challenging day. So doing those additional steps to solve by substitution can be kind of frustrating sometimes. So that's why I thought throwing elimination at you at the very last day of the week was going to be perfect. I love this one. I hope you guys do too. So starting off, I give you a nice little definition of elimination. So in general, it means the complete removal or destruction of something. In sports, it generally means the exclusion of someone or something from consideration. Of course, I had to add this one. Miss Deary knows all about my poop emoji in there right now. I texted it to her. So elimination can also mean the expulsion of waste matter from the body. Literally, it means poop. And the mathematical definition, which is really the only one we care about, but it's not as funny without the rest of them, is the removal of a variable from an equation. So that's the one we're going to focus on. We're going to remove a variable from an equation. So I wrote it out for you guys, and I'm just going to read this to you in case you can't read it from there. I don't know if it's blurry. So this says, the elimination method is another algebraic method used to solve systems of equations. It involves using vertical addition to add like terms and eliminate a variable. This happens when two coefficients are the same number but different sign. When you add them together, they cancel out, leaving you with a new equation that only involves one variable. That is something you know how to solve. Finish it out by using that answer to find the second variable. Check your work by plugging your solutions in or graphing it and looking for the intersection. So check it out. If you guys think back to vertical addition, that's like, old school addition when you're like, well, 22 plus 13, you add the ones, right? That's a like term, the ones, and then you add the tens, and you get your answer. We're going to be doing that here too. Before we do elimination, let's look at our other methods, because then it's going to show us how valuable this new method really can be. So if I were to solve by graphing, you could either plug it into Desmos, or we could take this first one, and we could solve it for y. So if I were to solve this equation for the y value, I would subtract the 2x to the other side and then divide by -1. So it would be 2x plus 1. Not really a big deal, but some added steps. So my intercept is 1 and my slope is 2. And I could go the other direction. Okay, I'll just draw that in. All right, hopefully by now we've gotten really good at graphing and this isn't too challenging. If I'm gonna graph the second one, I also need to get y alone again. So what I would do is subtract the x from both sides. And then I would be ready to graph. So, intercept of 4, slope of -1. Oh, we found our solution. Okay, I'm gonna draw this in. And now we're able to visually identify that solution. So the point where they're crossing is right here. And that's at the ordered pair, 1 and 3. So there's our first method that we learned. Then we learned to do this using substitution. Substitution says we need to get one of the variables alone in one of the equations. So let's say we had solved this one for y and we got this, right? So we would say, well, if y equals all of this stuff, actually, let's say we had them both alone. We're going to set it equal to this one. So we would have 2x plus 1 equals -x plus 4. And we would solve. Separate it down the middle, move my variables to the left, move my constant to the right, divide by 3, and then we would just need to plug that back into one of the equations. So maybe into this one. So I would have y equals negative our x value plus 4. So y equals 3. So my ordered pair would be 1 and 3, which is the same thing we got when we graphed. Now that we've seen this problem done by graphing, which we learned first, substitution, which we just did yesterday, now I'd like you to see how much fun this is going to be with elimination. I'm going to start just by rewriting that equation so we have it all in one place. So 2x minus y equals -1, and x plus y equals 4. Okay, remember this vertical addition, that's what we're gonna do. I'm literally going to vertically add these things together. Watch what happens. 2x plus 1x is 3x. Negative y plus positive y is 0y. They cancel, they eliminate. -1 plus 4 is 3. Look, 3x equals 3. We know how to do that. That means x is 1. Now I just need to plug it back into one of those equations to find the y value. Let's go into this one. So 1 plus y is equal to 4, which means y is equal to 3. So that gives me the same ordered pair we got before, 1 and 3. It just happened in 2 steps instead of a bunch. So this is my favorite. I love this method. I think it's really fun. I love that we get to use that old school vertical addition, and I love canceling things out. So on the back of this page, you're gonna see the same problems as yesterday, but this time we're gonna solve them using elimination. So I will do the first 2 with you, and then you guys are responsible for the next 2. Here's my favorite part. Ready? Add vertically. See these two, -2y and +2y? Cancel. X plus x is 2x. 4 plus 0 is 4. Now I know that x is equal to 2. And I can plug that back in to find my y value. So I'm going to say 2 plus 2y equals 0. Subtract the 2 from both sides. And divide by 2. Okay, next problem. We're going to get ready for our vertical addition. Take a look to see if any of your coefficients are the same number but opposite sign. See my y's? 2x plus 3x is 5x. 6 plus 9 is 15. This tells me that x is equal to 3. Now I'm just going to plug that back into one of the equations. It does not matter which one. I'm going to go into this one. And I'm going to have 3 times 3 plus y equals 9. So this means 9 plus y equals 9. So if I subtract 9 from both sides, y equals 0. All right, the next 2 problems are your responsibility. So you can, at this point, hit pause, give them a try on your own, and come back when you're ready for the answers.